In this video, we're going to be talking about classifying scatter plots, and then we're going to do some examples of fitting a quadratic model to some data points. Let's begin by talking about classifying our scatter plots. So we need to decide here whether each set of data could be better modeled by a linear model or a quadratic model or neither. So again, a linear model, quadratic model, or a linear model. So if we take a look at our first scatter plot, it doesn't really look like a straight line, nor does it look like a part of a U, so this one's probably going to be our neither. As we move to our next one, this one looks like it's more of a quadratic type of a model, although it's only the right-hand side of a quadratic model. And then our last one, this appears to be that our points are kind of forming a straight line, so this would be linear. So it's really about the shape that our points make on our scatter plot. Let's do an example. So a study was done to compare the speed, x in miles per hour, with the mileage, y in miles per gallon of an automobile, and we have the following results in this table. So we're going to be using a graphing utility to sketch our scatter plot. So what we want to do is enter in our values into our calculator. So what we're going to do is we're going to go to Stat and then Edit. And if there's things inside of your list, you'll need to go up to the top and clear them out and then enter in your data. I've actually already entered in my data for this table. And so go ahead and pause this video and enter the data into your calculator. And then when you're done, push play and we'll keep going. So now that we have our data entered in, we want to make sure our stat plot is turned on. So we'll go to second y equals, and we'll turn on our stat plot. So we'll go ahead and say on. And now we just need to adjust our window so that it fits our measurements. So here we have a minimum value of 15 and a maximum value of about 75. So let's make our x window go from 0 to 80, and let's count by tens. For our y values, it seems like we have a low of 22.3 and a high of about 30. So let's go ahead and we'll take this from 0 to 40, and let's count by fives here. So we'll go ahead and then we will graph. And now we can see that this appears to be a quadratic model. So again, a quadratic model. So now it's asking us to use the regression feature on the graphing utility to find a model that fits the data the best. So to do that, we're going to go and we're going to click on Stat. Then we're going to arrow over to Calculate. And we're going to do the quadratic regression model, which is option number 5. So we'll hit Enter. And we'll use the list that we entered in, and we'll calculate it. And here it's going to give us our A, our B, and our C that we will put into our quadratic model. So when we do that, when we write it, it will come out as follows. F of x equals negative 0.0082x squared plus 0.75x plus 13.5. Now it's asking us the approximate speed at which the mileage is the greatest. When it's talking about the greatest, what it's really referring to here is the maximum value. So we're going to calculate our maximum value. So we're going to go into our y equals, and we're going to enter in our equation. And once we have that entered in, we're going to go ahead and hit graph. And now we'll see our line of fit against our scatter plot, and now we can find our maximum. So to do that, we're going to use calculate, but not in the stat menu. We're going to use it up here in our graphing menu by trace. We'll hit second trace, which activates our calculating menu, and we want the maximum, which is option number 4. So we need to be to the left side of our peak, and then we'll need to make sure that we move over to the right side of our peak as well. And we'll calculate that, and we'll find a maximum of 45.7 and 30.6. So we'll go ahead and we'll round that to 46,31. So what does that mean? It means that at a speed of 46 miles per hour, we get the maximum gas mileage of 31 miles per gallon. Let's do another one. So here we have that a basketball is dropped from a height of about 5.25 feet, and the height of the basketball is recorded 23 times at intervals of about 0.02 seconds. The results are shown in the table here, using a graphing utility to find a model that best fits the data. Then, use the model to predict the time when the basketball will hit the ground. So what I'm going to have you do is go ahead and pull up your graphing calculator and enter these values into your stat list. So once you have those put in, then you just need to simply adjust your window so you'll be able to see your stat plot. So for our window, we'll look at our minimums and maximums for our x and y. So here we'll have an x minimum of 0 and a maximum of 0.6, and we'll go by 0.1 seconds. For our y minimum, we'll have a height of 0 and a maximum height of 6, and then go by 1 second intervals. And when we graph that scatter plot, here we see what also looks like a quadratic model. So now we'll calculate our quadratic regression, which is option number 5, to get our quadratic model, and we'll go ahead and write that down. And so we have f of x equals negative 15.449x squared minus 1.30x plus 5.2. And it asks us to use the model to predict the time when the basketball would hit the ground. So what that means is that we want the zeros. And so we're going to go ahead and use the quadratic equation to solve this. So go ahead and push pause, plug this into your calculator, and get your two answers. And then when you're done, push play, and we'll go from there. So for our answers, you'll notice that one is positive and one is negative. Well, we're only going to take the positive answer. And so we're going to have the x is approximately 0.54. Now what that means is that after 0.54 seconds, the ball will hit the floor, which is our solution. And we're done.